we will explain the process of using the application compiler on real programs. Gene and John will give me some assistance in explaining some of the finer points of using this product. There are 5 steps to making full use of the application compiler. At each step, we will answer those questions which our users have asked us about. Let's begin by looking at the process of creating a build file. John, how would you write a build file which compiles most source files with one set of options and a few others with a different set?
The simplistic approach would be to list all of the source files individually and list the compiler options next to each file name. A more sophisticated approach would be to put the source files together in a directory, list the directory name in the build file with the normal options, and list the individual files with non-standard options. This build file shows this approach.
Gene, how should someone write a build file when their include files are in a different directory from their source files?
I would use the -I compile option with the source specification, or use the -I compile option with the flags variables. This build file shows the latter approach.
Some people have asked, can I mix ANSI and common usage C codes in the same build file? The answer is no. The reason is you can't mix ANSI and common usage libraries. As you see in the example build file here, if you use common usage C, you must specify the compile option -PCC both as a compile option and as a link option. By default, the name of the executable generated is the name of the directory containing the build file. Some users have asked, how do I make the name of the executable to be different from that of the source directory? How have you answered this, John?
They should use -O on the build command line in the options command as shown in this build file. A common mistake that many people have made is to put the -O option on the link line.
Many of our customers are experienced users of Unix. They already have makefiles for their applications. Gene, is there a simple way to convert an existing makefile to a build file?
For many people, the best way is to use the conversion script supplied with the application compiler. Here we see how to invoke it so that it creates a Fortran link line. It's a filter which reads a makefile and outputs a build file.
John, how would you recommend creating a build file for an application that has both C and Fortran sources?
I would begin by listing the files or directories in the build file as usual. The application compiler will use the F or C file extensions to determine the source language of the file. I would then add assignments to the C flags or F flags variables as needed, then specify the language of the main procedure on the link line. This build file demonstrates this technique. If the main was written in C, but you call Fortran runtime libraries, list those libraries also on the link line.
Gene, we occasionally see applications which are missing source for one or more procedures. How would you create a build file in such a case?
The best way is to create annotations for the procedures you call. We'll discuss those in a moment. A shortcut method is to use the -permit unannotated option. This tells the application compiler to make pessimistic assumptions about the behavior of the called procedure. The object file is listed on the link line.
Gene, what about the related problem of applications which have code written in assembly language rather than a high-level language?
Assembly files can be treated the same as object files once they've been assembled. This is a good example of when it makes sense to have both a makefile and a build file. Use the makefile to call the assembler and create the build file, and then call build to create the application. Once the objects have been created, they can be handled with the -permit unannotated option to build, or by creating annotations for the procedures which are called. If you annotate procedures, the annotations must be merged into the object before calling build.
It is important to understand why annotations are necessary when source code is not available to the application compiler. Annotations enable the application compiler to perform inter-procedural analysis as if you provided source for the annotated object file. When you merge annotations into an object file, a new section, like the text or data sections, is created in that file. It contains interface definitions for procedures and side effect information on procedures. The application compiler reads this section when it finds calls to procedures defined in that object file. Here we see the annotation for a procedure. The procedure itself might have been written in assembly language, or C, or Fortran, but in this case the annotation itself is written in Fortran. Annotations contain two kinds of information: procedure interfaces and side effects. This particular annotation tells us that this function takes one floating point argument and returns a floating point result. The function doesn't modify any of its arguments, nor any global variables. Several of the most important convex system libraries are shipped already annotated. John, how about user libraries? Can annotation be used with them as well?
Yes, they can. Users can find themselves in one of two situations. Either they have the source to the library available to them, or they don't. But in either case, if they know enough information about the library procedures to use them correctly, then they know enough information to create annotations. The key concept here is to generate annotations only for the procedures your application actually calls. The application compiler will list the library functions for which there is no annotation before it stops. It will only list functions which are actually invoked somewhere in the code. If the user has the library code, just strip out the procedure headers and declarations and put them into a file. If not, type them in, then add the appropriate procedure summary directives which provide the side effects information. Finally, merge the annotations into the objects in the archive.
Let's answer one final question about build files. Since they serve an analogous purpose as makefiles, why not just use makefiles directly? There are several reasons for not using makefiles directly. First, makefiles contain a great deal of information that would be ignored by the application compiler. Makefiles consist of macros, dependency information, and actions. While make forces the user to code dependency information explicitly, build deduces it automatically. If makefile dependency data is wrong, an application may be built incorrectly. This cannot happen with the build. Second, makefiles contain some actions which build cannot honor. Make allows you to specify alternate compilers, assemblers, and linkers. The application compiler is a unit and can only use the compilers, assembler, and linker which have been modified to understand interprocedural information. Make forces you to explicitly code the link step. Build cannot allow you to code the link step since you cannot know in advance the names of the object files it will actually create. Third, build files contain a number of commands explicitly requested by our field test users which do not fit into the syntax or semantics of makefiles. These include options, inline, no inline, clone, no alias, and force object. Now let's turn to the process of actually compiling an application. The application compiler terminates compilation prematurely when it finds certain errors in an application. This happens because the IP analysis algorithms cannot compute meaningful information for the code as written. These errors are analogous to a syntax error in a procedure compilation. If a parenthesis is missing, no parse tree can be formed by a procedural compiler. If a procedure is missing, no call tree can be formed by an inter-procedural compiler. There are three general areas in which the application compiler must be able to complete its analyses in order for compilation to complete. It must be able to construct a valid call tree. It must be able to associate every formal argument in a procedure with an actual argument in each invocation of that procedure. Finally, it must be able to create a symbol table for the entire program. Interprocedural analysis depends on having a valid call tree. When the application compiler reports the following errors, it is unable to construct this data structure. A procedure is addressed but not defined. There is an unresolved procedure symbol. More than one main entry point has been found, or no main entry point can be found. A function is multiply defined in 2 or more files. You cannot redeclare a function as static if it is already declared extern. Interprocedural analysis depends upon being able to associate data from formal to actual arguments. When the application compiler reports the following errors, it is unable to make this association. The call to a specified function has fewer arguments than the definition, or an actual and formal argument pair have differing types which take up different amounts of storage. Interprocedural analysis depends upon being able to create a program-wide symbol table. When the application compiler reports the following errors, it is unable to create this data structure. A specified variable is initialized in 2 or more files. A specified variable is declared inconsistently in 2 or more files. When you are ready to use the application compiler, you should put the path to the application compiler in your shell path variable. For the users of the C shell, you would want to edit your .cshrc file. The application compiler is stored in the directory user convex IPO bin. Having made the program accessible, you can now simply say build. If you want to provide command line options to build, you can do so, or you can embed them in the build file using the options command. One of the big differences between the application compiler and traditional compilers is that it maintains a program database. This means that users must manage disk space in ways they have not done before. One of the first questions which arises is, how do I know whether my disk has enough space for the program database? Jean, how would you answer this?
The actual space required varies depending on the application. In general, the more accurate the analysis and the more inter-procedural optimizations performed, the larger the database. You can make a rough approximation by doing the following. Count the number of non-comment source lines, multiply by 1,000 to get the number of bytes required.
John, what should a user do if the file system which contains his source code isn't big enough to hold the program database too?
If they can't make space any other way, they should use the build option -path to store the PDB in another file system. The example shown here embeds the -path option in the build file. Note that the path specifies the directory which will hold the database directory. The name of the database directory will always be PDB and should not be supplied as part of the path.
Jean, here are a couple of related questions. How can a user monitor the compilation of a large application? And how can I know which compiler options were used in compiling my source files?
In both cases, the answer is to use the build verbose option -v. During the analysis and compile phases, this will cause the application compiler to list each source file being processed and the compiler options being applied for that file. During the synthesis phase, the compiler will list each inter-procedural analysis algorithm as it is processed.
Of course, there are always people who want less output rather than more. They can use the build silent option, -s, to turn off all messages from build and the inter-procedural algorithms, as shown in this example. They might also want to use -nw-or none to turn off all messages from the analysis and compile phases as well. Inter-procedural compilation will always take longer than procedural compilation. The application compiler does more work than a traditional compiler does, and while we do expect some improvements in compile speeds over time, it is safe to assume that it will always take at least twice as long as a standard compiler to produce an executable. There are some things that a user can do to make compiles go as quickly as possible. First, use the -path option to put your program database on the fastest available disk. Second, the application compiler can run its analysis and compile phases in parallel, but runs only one process at a time by default. If you use a multiprocessor system, you can tell the application compiler to use more than one process. We recommend specifying 2 processes for each processor. So, on a Convex C220, you would specify build-J4. This option should be used only if the CPU is not fully used on the system. Finally, you can ask your system administrator to increase the swap space on your system. John, some of our users have experienced problems with the application compiler terminating prematurely with a SIG trap. Why does this happen, and what can be done about it?
The application compiler uses memory-mapped I/O in order to get the best possible performance. This means that the entire database will be in memory when possible. It also means that your system needs enough swap space to hold the entire program image, which can get large if you are compiling a large application. The SIG trap occurs when the program has run out of disk space to store the image of your program. Ask your system administrator to increase swap space.
A frequently asked question is, what is the meaning of the permit invalid Fortran option, and what is it used for? All Fortran compilers generate code assuming that dummy arguments and common variables are not aliases if they are assigned. If a Fortran programmer violates this assumption, the compiler might generate an invalid program. The application compiler finds such violations and by default will not generate code for such applications. These problems are found before most of the inter-procedural algorithms execute, and if they are found, compilation is terminated prematurely. -permit invalid Fortran enables the programmer to continue compilation in order to get all the error messages. Gene, what is the no alias command used for?
After fixing the other problems found by the application compiler, we recommend that the programmer remove the -permit invalid Fortran option and analyze and correct the aliasing problems reported. The aliasing algorithm works on the basis of names, not individual array elements. This means that it can report potential aliasing problems which do not actually occur in practice. If two elements of the same array are passed, but the call procedure never accesses the same element by the two different argument names, then use the no alias command. Both aliases between two dummy arguments and between a dummy argument and a common variable can be handled this way.
Gene, is it possible to interrupt the application compiler and restart it?
No, we don't recommend it. The database may be in an inconsistent state. If you must kill a compile, remove the database before trying again. The screen shows how to remove the database.
John, is it possible to use the linker to make an application from object files generated by the application compiler and those generated by the procedure compilers?
In general, no. The application compiler generates object files which differ from those generated by the procedure compilers. It renames procedures and variables, it puts each procedure in a separate object file, and it puts global variables in separate object files.
Gene, when you have been debugging an application or were trying to understand its performance, I'm sure you have needed to look at the assembly language version of the object files. How do you obtain assembly output from the application compiler?
Use the -s compile option as shown here. Assembly files are placed in the PDB directory. Note that assembly files are generated on a per procedure rather than on a per source file basis.
The next step in using the application compiler is to review the output. Let's start with the default output. John, how should someone use the information in the final reports?
There is a lot of important information in the application compiler reports. The first report provides information on optimizations performed. Each line gives the total number of times each optimization was performed for the designated procedure. Scan this report looking for optimizations you expected to be performed, and if they weren't, use build file commands or source directives to assist the compiler. The second report provides information on errors detected. Each line gives the total number of times each error was found for the designated procedure. Scan this report looking for procedures which have errors, and then get the details so you can fix them. The line at the bottom of each of the reports shows how to get more information on that particular column. It lists the -show or -check option, which will give the details for the summary information shown in the table.
Gene, have you ever compiled an application thinking it would be error-free and then realized when you looked at the reports you needed to see the details? What did you do?
Yes, this does happen. Fortunately, you don't need to recompile the entire application in order to see the details which the final reports summarize. The application compiler stores all information produced by the -show and -check in the database and can replay it with the -display option.
What does the -show aliases report mean? What should it be used for?
It lists warnings about all aliases between dummy arguments and common variables. Such aliases are not errors unless one of the aliased names is assigned. The main use of the output from this report is to track down the source of aliases which are in fact errors.
Gene, what does the -show arrays report mean? How do you use it?
The table which is produced shows the geometry of index references for every array which is used or assigned in every procedure, directly or indirectly. Use this output to determine why the -check arrays report says an array has invalid subscripts, or the -check init report says the array is uninitialized.
John, how does one read the -show calls report? What have you used it for?
The listing shows the call tree for the application. The level of the subroutine is shown with a number on the left. Recursive calls are marked with 3 angle brackets. Duplicate subtrees are omitted with 3 dots. I use this output to understand messages about functions not called. It is also useful when tracking down invalid aliases.
What does the -show clones report contain? When do you use it?
The listing contains one message for each clone created. It specifies the original procedure, the call location, and the constants propagated. Use this output when determining whether to specify additional cloning.
What about the show constants report? What does it tell you? What have you used it for?
Well, the listing contains one message for each procedure called. It specifies the interface variables and their constant values. I used this output when determining whether to specify additional cloning.
Some people get confused by the fact that there are often many more constants on entry reported during synthesis than there are propagated constants during the compile phase. Propagated constants are those which are actually used. The constants on entry set includes all global variables which are known to be constant on entry to any given procedure. Of course, there are likely to be many global variables known to be constant which are not used by a particular procedure, and this is the source of the difference. Gene, what information does the show inline report provide? When have you looked at it?
Full details on inlining actually performed are given in the optimization report for each procedure. The -show inline report tells you which calls the inline analysis algorithm thought were profitable to inline. Some of these calls marked for inlining may not actually be inlined if the coding style used prevents this. I recommend using this report when determining whether to specify additional inlining, particularly whether to use -permit dynamic binding.
We know the pointer tracking is meant for C codes. What does the -show pointers report tell the C programmer?
This report gives the list of targets associated with each global or argument pointer variable which is used or assigned directly or indirectly in each function. This output can be helpful in determining why a loop didn't vectorize in a C program. It only provides inter-procedural information, however, so you won't see the targets of local pointers.
Gene, what does the show renames report tell you? When would you use it?
The application compiler must rename certain procedures and variables in order to preserve the original meaning of the program when it performs inter-procedural optimization. The objects renamed are cloned procedures, Fortran entry points, Fortran static variables in inlined routines, and C file scope static variables. This output is necessary when running an executable generated by the application compiler under a source-level debugger. Without it, you won't be able to set breakpoints or display values of the renamed objects.
What does the show types report mean?
This report gives the types of actual and formal arguments for each situation where the application compiler detects a type mismatch. These type conflicts are not considered fatal compilation errors because both the formal and actual argument types take the same amount of space, even though they are represented differently. This output is useful in ensuring that you aren't misusing arguments by passing them to a variable of the wrong data type.
The next step in the process is to correct the errors found by the application compiler. Gene, what kind of problems does the -check types report find?
This report lists all formal actual argument pairs which the application compiler finds to have incompatible types.
What problems does the -check arrays report identify for you?
This report lists arrays which may be used or assigned directly or indirectly in a procedure and whose subscripts may be invalid. It is important to understand that this report is flow insensitive. This means that it may list references as problems which can't occur in the execution because the references are guarded by conditional statements.
What sorts of errors does the -check init report help you find?
This report lists global arrays and scalars which may not have been statically initialized or assigned before use. Many Fortran programs rely on the common compiler behavior which initializes all variables in common to 0 by default. This report will list these as uninitialized. Use block data initialization to eliminate these false positives.
Is it possible to run a program generated by the application compiler under the CSD debugger? How do you do it?
Well, as shown here, you use the -db option both as a compile option and as a link option. It's probably wise to run the build with the -show renames option if you know you're going to be working with the debugger as well. Once the application is created, you run it under the debugger just as you always would. Our users should be aware that the new CXDB debugger will support vectorization, parallelization, or inter-procedural optimization in the future.
If a user of the application compiler intends to perform optimization beyond that which is done automatically, they will want to run a profile of the code. How do I create an executable that can run with the consultant profilers?
As shown here, you use the proper option, both as a compile option and as a link option. All three profilers will work as expected if compiled correctly. Remember that procedure clones and entry points will have new names. Some of our users have been able to use the CXPA profiler with the output of the application compiler, though we won't officially support it until version 1.1 of the application compiler.
Some users will find that they get different answers with an executable compiled with the application compiler than with other compilers. This can happen because the application compiler optimizations cause calculations to be performed in different but equally valid sequences. Numerical applications must either explicitly control the order of numerical operations or not be sensitive to different orders allowed by the language standard. John, how can a user determine whether different results are a problem with his code or with the application compiler?
It takes a four-step process to uncover these sorts of problems. First, you must repeatedly compile the application with a different inter-procedural optimization turned off. For instance, inline none or clone none, until you find the optimization causing the difference. Second, you must repeatedly bisect the procedures with this optimization turned off for half and on for half until you find the procedure causing the difference. Third, you must compile that procedure with various optimization levels. For instance, no, O0, O1, or O2 to determine what kind of code reordering optimizations are involved in the differences. Finally, you may need to investigate the individual ordering of operations within the procedure to find the numerical instability in the code, if one exists. You can use parentheses to force operation ordering within statements.
Some users have had problems getting applications which pass holoriths as arguments to compile with the application compiler. How should they handle these?
If a program passes holoriths as arguments to character variables, it is neither a standard conforming Fortran 66 nor a Fortran 77 program. The Fortran 66 standard didn't have character variables, and the Fortran 77 standard requires that holoriths only be passed to integer, real, or logical variables. Compilers must either pass multiple arguments or special descriptors for character arguments. These are not passed for holorith arguments. This is why the standard doesn't allow this usage. The programmer should make either of these changes. 1, convert the holorith actual arguments to character constants, or 2, convert the character dummy arguments to integer.
The final step in the process of using the application compiler is to add optimizations using build file commands and source directives. Some users have wondered whether the application compiler will work with code which has had directives like no recurrence inserted in it. The answer is yes. The application compiler is fully compatible with the Convex Fortran and C compilers. Others have asked whether they still need to use the -UO compiler option to get vector pattern matching. The answer is no. Pattern matching has been enhanced in the application compiler and is performed by default. Jean, when is it appropriate to use the -clone option?
I use the -clone none when I'm debugging a code and I think cloning might be part of a problem. I don't normally use -clone all because it can make the resulting executable much bigger. If the user is willing to live with that, it would make good sense if he knows that there are important constants which might be propagated with this option that are not being propagated by default.
John, when do you use the -inline option?
I use -inline none when I'm debugging code, and I think inlining might be part of the problem. We suggest using -inline low if you need to decrease the size of the executable, but still want some calls inlined. If you're willing to try some experimenting, it can make sense to use the low or high options for inlining. Try the low option if the percentage of calls inlined was very high. Occasionally, a little less inlining can improve performance. Try -inline high if the percentage of inline procedures seemed low. Occasionally, a little more inlining can improve performance. Automatic inlining is a heuristic rather than an algorithm with a deterministic result. Its parameters have been tuned by evaluating the performance of actual applications. The inline heuristic follows the philosophy, do no harm. The parameters were chosen conservatively, but even so, there will be cases where either the high or low options may give a little better performance.
Gene, what is the purpose of the permit dynamic binding option?
Dynamic binding must be used when the number of dimensions of the actual argument do not match the number of dimensions of the formal argument. Dynamic binding generates an extra memory reference for each address calculation. This means that dynamic binding can actually slow down an application, and so it is not done by default. Don't use it unless you're prepared to time both versions of the program and choose the best one. Use -permit dynamic binding when there is a call you want inlined which the application compiler says it can't inline because of mismatched argument types. That is to say, they have a different number of dimensions.
John, when do you use the inline and no inline build commands?
I use the inline command when there are specific procedures I want to be inlined, but the default algorithm is not choosing them. I use the no inline command when there are specific procedures I think aren't worth inlining, but the default algorithm is choosing them. These commands are particularly useful if you cannot change the source by adding directives, perhaps because you want to maintain a single source for multiple systems.
What about the inlining source directives? When do you use them?
The inline and no inline directives serve the same purpose as the build commands of the same name. I use the inline call and no inline call directives to force or prevent inlining of a specific procedure call. If I knew that most of the calls to a procedure weren't worth inlining, but one particular one was, and for some reason the default analysis didn't choose it, I would use the directives. We use the name list forms of the inline call and no inline call directives relatively infrequently. They are useful for forcing or preventing inlining of a specific function call in an expression having several function calls.
Gene, when do you use the clone and no clone build commands?
When there are procedures I think should be cloned and the default algorithm is not choosing them, I use the clone command. I use the no clone command when there are procedures I think should not be cloned but the application compiler is choosing them. If you cannot change the source by adding directives, perhaps because you want to maintain a single source for multiple systems, these commands are particularly useful.
And the cloning source directives, when do you use them?
The clone and no clone directives serve the same purpose as the build commands of the same name. The name list forms of the clone directive are used to increase cloning based upon potentially constant values for specific arguments. Similarly, cloning can be restricted with the name list form of the no clone directive.
The application compiler has broken some new ground for Convex in providing directives which give hints to the compiler rather than providing commands. Using the condition true source directive can help inter-procedural analysis be more effective when the conditional statement has the same truth value most of the time and there are procedure calls controlled by the conditional. Using the estimated trips source directive can help inter-procedural analysis be more effective when the loop has either fewer than 10 iterations or more than 100 iterations most of the time, and there are procedure calls in the loop. Convex is committed to continue our leadership in software technology. The application compiler is the first complete integrated product which uses the results of research into inter-procedural analysis. In fact, it extends current research with the innovation of pointer tracking in C. This feature also demonstrates the Convex commitment to provide support for every language which significant numbers of our customers want to use. I'd like to thank my guests for helping me to explain how real users of the application compiler are applying this new technology to develop applications which are more reliable and which produce results more quickly.